Thanks for the opportunity to talk to all the INFOMAR stakeholders today. I just want to give a very quick update on where we are with marine climate change, and Kieran kind of touched on that, and I think Javi will as well in the next talk. But just to give you a sense of where the thinking is on climate services really in the Marine Institute over the next 10 minutes or so. And just like to acknowledge that Caroline Cusack and Deirdre Fitzhenry in particular in the Oceanographic and Climate Services team are a great help in pulling together this presentation. So there's an interesting landscape at the national level for marine climate services. So this is the landscape at national level, various adaptation plans that feed into the climate action plan. And you'll see that there's 12 adaptation plans across 7 government departments that are currently in place. So these were produced in 2019 and updated, or will be updated very, very soon. And in the bottom panel, we've kind of been doing a little bit of soul searching in the Marine Institute to see how we can configure the science that we do, the infrastructure that we have, the different people that we have around the system, projects that we fund externally and so on to deliver into various adaptation plans. The red arrow there signifies the link to our parent department and the seafood sector adaptation plan, which is probably the biggest focus that we have, but it doesn't mean that we can't work in partnership with other state organizations to deliver services to some of them as well. So the framework for climate services within the Marine Institute, we need to harvest all the different requirements that you saw on the previous slide from as many of those adaptation plans as is necessary. And then we have 3 pillars, if you like, of the climate services that then seek to address those requirements. We have an observations pillar, all the different things that we measure out in the ocean. We need to increase our understanding of the key processes to deliver climate services. And we need to also be able to project what's going to happen in the future. And I think the key take home from this is that we would try to do this in what you would call a co-development environment. We've already had some discussions with GSI, EPA and many other stakeholders about how we co-develop climate services, and indeed with Met Éireann, because a lot of the applications, they traverse the marine and atmospheric boundaries. So you can't really look at things in isolation anymore. It has to be multidisciplinary, multi-agency, multi-department approach. So we've, as I mentioned at the start, we've done a bit of soul searching within the MI, and we have about 28 people involved in climate work. But unfortunately, it's very few of those people's day jobs to work on climate related activity. If you sum up the 28 of them, it adds up to about 1.5 full-time equivalents. And we also fund a lot of external projects, and we're involved in other climate projects. When you look at those externally funded projects, we have about 21 full-time equivalents in those. And we fund a few MSCs and PhDs as well. And we have various pieces of infrastructure that you can see on the right of this slide, including the research vessels that Aidan talked about, gliders, sea level gauges, the glass gauges, the marine data buoy network, and so on. So we've quite a complex ecosystem and largely an outsourced model for providing climate services at the moment. We have 3 major deliverables from our climate program this year. The first one is a baseline report on essential ocean variables. That's complete. So we've looked at all of the essential ocean variables that are listed by Global Ocean Observing System, and we've looked at our state of readiness for all of those variables. And that report is available, and I'm happy to circulate it to anybody who's interested in it. I have a couple of snapshots into it in a couple of moments. We're developing, it's an internal report, what we call a climate foresight report or a roadmap, to see how Marine Institute might configure itself in the future to provide climate services. That'll be published in the next 2 weeks, I would say. And the other major report we're doing is an update of the 2009 Ocean Climate and Ecosystem State Report to summarize what has happened in all the major parts of food webs, ocean chemistry, and ocean physics over the last couple of decades. And that will be produced in Q1 of 2022. So just to give you a flavor of what was in this baseline report that I talked about, we looked at it by essential ocean variable, and you can see 3 of those essential ocean variables here. In the left-hand panel, we have what you call a heat map of sea surface temperature. So this is a combination of the different buoys that are located around the coast, some coastal stations at Ballycotton and Malin Head, and then also superimposed on that the vessel underway sea surface temperature data. So you can see the hotspots around Galway, Cork and Dublin, where we tend to have an awful lot of data. I'd say we have very good data coverage at each of the buoy locations that you see there as well. And these heat maps give us an idea of where we're doing a good job of monitoring some of these essential variables. The middle panel is of ocean carbon. So we've had quite an active program out in the Rockall Trough for 2000, since about 2005 or 6. And we have routine monitoring around the coast as well for dissolved inorganic carbon. So that there are those transects that you can see quite close to the coast that extend offshore. And on the fishery side, the right-hand panel, you can see some examples of fish distribution from the various major surveys that we do on behalf of the government in any given year. So fish distribution and abundance is actually essential. It is an essential ocean variable, and we want just to understand the data sets that we've collected, and this is between 2008 and 2020. That's just a close-up of the heat map for temperature. We've done this for all the different essential ocean variables. The other thing that we've done is we've worked very closely with our colleagues in ICHEC, in the Irish Centre for High-End Computing, to downscale. A couple of people earlier mentioned the IPCC, the Intergovernmental Panel for Climate Change. They produce model outputs and projections at quite a coarse scale. That's quite a challenge to use in an Irish context. And what Paul Nolan and colleagues in ICHEC have done is they've downscaled the IPCC, what they call the CMIP6 projections, to Irish waters. And you can see the domains of interest there in the panel on the left-hand side. I've always talked to Tommy and Kuhn Verbruggen and colleagues about mapping the Celtic Sea because it's a very important area, and it's great to see in the presentations earlier that mapping is still ongoing, and we're gradually building up a picture of the Celtic Sea. But we are developing a projection model for the Celtic Sea that is shown by the red box on the panel on the right. And that'll be a biophysical model. It's a project called BioCeltic, funded under the European Maritime and Fisheries Fund. And we hope to have results from that model under several emission path scenarios available in the next 2 to 3 months. And we'll have, as I say, both biological, chemical, and physical variables within that model domain available for anybody who wants to use those projections. The other thing that we've done, it may be interesting to some people more focused on the biological aspects of our waters. As part of the Coastline project, we've developed a model of the southwest coast of Ireland. And one of the things we've looked at is heat waves. So marine heat wave is when the temperature exceeds a particular threshold for 5 days in a row, basically exceeds the long-term mean. And we can look at the duration of these events. We can look at whether they're going to become more frequent or not. And this is just an example from Danish Island, which is an aquaculture site. And I think the first presentation actually focused in on some of the mapping down in that area earlier this year. And we can see these peaks, these red peaks in the panels on the right-hand side for surface and bottom waters, where you have marine heat waves that have an effect on aquaculture and on juvenile fisheries and so on. And we can do this from 1970 to 2035 now. So we have those data stored, and over the next couple of years, we'll extend the climate projections to cover the entire Irish coastal area and more state variables in the model as well, so that we can underpin policy advice with that as well. Final thing I wanted to show was it was one of the interesting things we picked up from our interactions with stakeholders on the climate side of things is we have climate action regional offices within many of the local authorities. And typically what happens there is that non-specialist staff, so these would be people without a scientific or engineering background, they end up working in the climate action regional office because they know climate is a very interesting and fascinating area. And one of the challenges they have is to actually explain climate change to the public. And this is just an example of a recent infographic that we did with the climate action regional offices on harmful algal blooms, just to explain what a harmful algal bloom is, what are the effects of a bloom, how is it likely to change over time, and what preparedness can we put in place to mitigate the effects of harmful algal blooms in the future. So we're continuing this work in ocean climate literacy, if you want to call it that. We're continuing our work in beefing up our observations in an Irish context, and we're continuing our work in terms of understanding climate impacts and also in terms of projecting what's going to happen in the future. And that hopefully provides some form of overview of our active areas of work in the climate area at the moment. Thank you very much.